Thanks for being here today. I'm Davit, engineering manager at Softr, and today I will talk about engineering management in the age of AI and how to become from manager to multiplier in these interesting times. Before I will start the presentation, I would like to ask a few questions to understand the audience. Who was born before 90s? Could you please raise hands? And who was born from 19th to 2000s? And maybe a few people who was born after 2010? Okay, thank you. So for some of you, maybe I will tell a bit wild story, what was software engineering before AI. So in the beginning, before 19th, software engineering wasn't like you know it today. So people usually went to universities, get education, some technical background, they read a lot of books, and then started to use these huge mainframes, then huge computers with very limited computational power and very limited things to do. And actually at that time, the only skill and knowledge was in your brain, so you should have the knowledge to write source code, or you should refer or open the books, do some manual research, which took a lot of time to write a code, and actually the final product wasn't as powerful as software products are now. Then things become much better when first Pentium computers became and the computational power started to increase. We started to use CDs, and for instance, this is an image of MSDN. I think few of you know what is this, but when I started my career, this was the best place. It was a Google, Cloud, Cursor, and everything, because those 4 CDs contained a lot of information which was needed to open and read, understand how to set styles to button, how to, I don't know, get text from input fields, etc. And also MSDN was very cool because it also had some precompiled source code, and it was sometimes easy to open the samples and understand how things are working. And this was significant change. I started at this moment my career. Then in the early 2000s, the internet became more popular. A lot of people started to put some read-only content, and we started to visit internet clubs. At that time, at least in Yerevan, there was no widely used internet at homes. Smart entrepreneurs started to open the internet clubs with dial-up connection, very limited speed, but at least it was something, and you can pay for hourly usage, went to the internet club, and then open browser, start to find what you want. Personally, I remember a case when in 2005, if I'm not mistaken, I, together with my friends, started to experiment one product to build a startup, and we need a source code. We were not able to write it, or then we went to Internet Club with the USB flash. We downloaded an example, bring it at home again, and started to modify it. So that was how we started to get information from more sources. And as you can see, this was huge improvement in terms of using CDs or books. Then in early 2010s, Stack Overflow was born, and this was a great source. I remember when I first time signed it up and posted my first question, then tried to answer to others' questions to improve my skills, get some badges, etc. This was a great source and like go-to place for me to find answer to a lot of questions. For sure, there were sometimes some answers which you apply and they don't work, and it was a bit not consistent, let's say. Not every answer was the correct answer, but this was again another huge milestone and another improvement for everyone. And we started to feel ourselves much more powerful. We started to deliver software much faster, etc. And what else can be introduced to improve our life at that moment? This was the top of the technologies. But then, sorry, this is, and later became the age of AI. Even a few years ago, 4 years, 5 years ago, AI wasn't as powerful as it is now. I remember the first time when I started to use AI at work, it was just like another smart autocomplete, and I even become nervous and turned it off because when I entered the tab or opened the brackets, it started to generate some code which wasn't useful at all. It was out of scope completely, and I wasn't able to see any value there. But what we have now, Claude, OpenAI, Lovable Cursor, and all other tools, so now it seems like you don't need to have a degree in computer science, you don't need to read a lot of books and experiment, because everyone, even, I don't know, taxi driver can open Claude and start writing code. So what was changed? As you can see, during those few decades, a lot of things were changed, and now it seems like everyone can code, but that's not true. That's what on surface and not the reality. And I would like today to talk about the challenges we all can see, and I personally see as a manager of a big team, and how we use AI, what are the upsides and downsides of those technologies. So what we have now, as you can see already in this timeline, starting from 18th till the current time. So a lot of things were changed. So software development is changing very fast, and it's super easy and super fast now to write source code. But source code is not the final product. And AI doing a lot of stuff, automating a lot of workflows. Small teams started to deliver big enterprise scale products. And a lot of people, as I said, started to contribute. Even in our company where I'm working, our product people, they now code because they use AI, they do small improvements, which was in the past, like their work was to create those tickets, then assign to someone in the team. But now they even don't want to spend software engineers' time on the small improvements, and they do the changes themselves. And as you can see, coding is no more the bottleneck, but what is important now is the clarity, system thinking, distribution, and decision making. Why those are important? Because if everyone can generate a code, doesn't matter the education and background, then how to understand, is this code good or bad? Can we trust this code or not? Can we release this code or not? So you need to understand what AI is generating, and you need to start thinking in a bigger scope, because the code, which in the past took, for instance, 6, 8, 10 hours for you to develop, now can be generated during a few minutes or even less. And you now need to understand the things from the top level to see how it fits with the current context. Because AI can generate a lot of stuff, sometimes without deep knowledge in the product. AI doesn't know the nuances. You need to give some skills, rules, etc., to make it work better. And even in that case, you need to check what it's producing. For instance, a few days ago, we found one bug which was introduced by me because I used AI in the project where I don't have deep knowledge, and from the first glance, the change was safe, but then we realized it introduced one bug because it changed, did a small change in the endpoint call, and it triggered an issue. So distribution is another issue. As now everyone can write a code, then we have a new challenge, how to distribute this product to the wider audience, how to get users, and how to generate revenue. And decision making, because sometimes, even when you use the most advanced models, and for instance the Claude, you have some skills, it's starting to ask you questions. How you want to proceed this case, what to do in this case, should I use out or only authentication via API key, for instance, you're writing a feature. So decision making is something that you should do, and you can't rely on AI and say, you know, I want an application like Uber, go and build. No, you need to provide a lot of inputs, you need to make decisions, and those things now become very important because coding is no more challenge, and the rest of the stuff is challenge actually. So traditional engineering organization in the past before AI, success was optimized around the team size, process perfection, delivery speed, communication, coordination, etc. And managers in the past more focused on hiring, correct decision making, resource allocation, and also managers at that time they thought how to improve the productivity of the team, what kind of tools we can buy, how we can optimize the current processes, solve dependencies, remove dependencies, and what can be improved overall. Now, most of those things are no more valid. And the old equation at that time was more people means more output, because in the past there were no AI, no code generation, so you need to have those guys and girls who will type the code and make the product. So if you have 3 people in your team, for sure they will deliver less than the team with the size of 10. But that's no more true, and AI changed everything. Now, single engineer can do work of multiple engineers. For instance, you are a strong engineer with good engineering background. For instance, you are not an expert in React, you are expert in backend technologies, but as you are an engineer, educated engineer, you can write prompts and overall understand, is generated React code right or wrong? Is it fitting good with your backend, and what to improve and how to go forward fast? So in the past, in the previous slide, I wrote that specialization as a success metric. So in the past, teams had front-end engineers, back-end engineers, QA engineers, etc., and those team members were specialized in different areas. Now it's much easier to have one person who can do everything because of his experience and education. So it's easy. And what AI also changed, so prototyping, in the past it maybe took weeks or months to do the MVP, show to customers, potential customers, show product to the investors. Now a lot of people are prototyping during a weekend, and after 10 days they already have a final product, they're starting to sell. And code generation is nearly instant because it takes literally seconds to generate a lot of code. And documentation, testing, debugging everywhere, AI is also helping us. Personally, I use AI a lot to update also README document, which was a headache in the past for developers. We always in the past had this README document, but it was always not up to date, and you can't refer to it. But now when AI is generating, for instance, your backend endpoints, it's also in parallel update the README file, so it's always up to date. And same for testing. You ask AI to generate some code, you also ask AI to generate end-to-end tests, I don't know, unit tests, integration tests for the source code. So no more need to do this manually, no more need to hire more people to cover all of this. I remember times when in the companies I worked, we hired a lot of technical writers because there was a lot of documentation to keep up to date. But now there is no need. Maybe someone just can take care overall for the all products documentation, and that's all. No more manual work. And the new role for managers. Now managers start to optimize leverage, speed of learning. They need to introduce AI workflows to automate the boring manual work, which is a lot still in many companies. They need to use AI to introduce more automation, and now managers' role is, I think, increased a lot in terms of product impact. Because if software engineers can use AI to generate the code, just on the high level check it's okay and go forward, they start to think about other things. In the same way, engineering managers, they are offloaded from the boring, or let's say the redundant manual work they did in the past, because it can be handled by AI. And now what else they should do? They have a lot of free time, so engineering managers should start taking care of those points and make their teams increase their performance, make teams much more productive. So new equation is leverage multiplied by clarity in systems. That's the new equation to calculate the output. So what is the leverage? We talked about it. Leverage means creating outsized impact with limited resources. And now AI, a lot of people use AI to replace a lot of manual work. They automate a lot of hours with just Zapier, Make, NA10, and similar tools. So small engineering teams operating like big enterprise teams, and product decisions now we make product decisions very fast because there are a lot of things to use to improve the productivity. And the role of engineers is expanding. As I said, now a lot of engineers, or everyone who are using AI tools, they offloaded their daily work, and now they need to think on the product level. They need to understand system design much better, to understand how this generated code fits existing design. They now need to design a lot of workflows to improve a lot of things and be more aware about the business. So time is a bit limited. I will try to talk fast to have some time for questions and answers. And from the engineering side, we need to start ask questions, why we are building this? Does this solve a real problem? Or is there a faster way to do something? Because especially now, there are more and more tools, more and more AI tools for different small niche problems we have every day at work, and you always need to ask this question because software is changing rapidly, development is changing rapidly, speed is very high. You need to understand what's new in the market, what you can use to improve your performance. And we need to understand also what creates actual value for customers, not just features, but value. And every people here now need to understand how to combine multiple AI tools, like use one AI tool to generate the UI for your mobile application, for instance, then give the screenshots to Cursor, for instance, and give Cursor skills related to Swift UI, for instance, and use all those different AI tools together to build better products, to validate things fast, and people now should take care about human plus AI collaboration because this is how we now generate source code and build reliable systems because AI can generate a lot of code, but it's not always what we want. Sometimes AI can take care about security, for instance, by default. So if someone working in a library and in the evenings building mobile applications for a library, this person is not an engineer. This person is not aware about security stuff, and this person will not just will not include the prompt to cover security cases, but you need to understand what AI is generating. Is it okay to push to production, or you will have a lot of problems later? So engineering becoming more so, architecture now matters more, integrations matter more, and system thinking matters more. And now, as I said, code generation takes seconds, and now boilerplate code is something AI can handle very well. Repetitive testing, documentation, I don't know, migrations, debugging, and people should start now more think about decision-making, prioritization, design, and product understanding. And now it's an interesting time because we see the rise of very small teams, like a lot of small companies using AI starting to produce big enterprise products, like 10 times, you can build the same product with 10 times, 20 times, sometimes less engineers, and you need now to understand how you can become an AI native startup. For instance, there are recently already a solopreneur created companies like Polsia, which more or less unicorn now, and it's an interesting time. In the past, becoming a unicorn took years, 5 years, 10 years, maybe 7 years if you are lucky. You should have a team of few hundred people, etc. Now we see already products which are less than 1 year, but they are already unicorns, and solo founders now build a lot. There are different people who are generating totally more than 1 million ARR, like Mark Luo, very famous person in LinkedIn, and tiny teams started to ship global products. So for leadership, for us, it's also very important to understand the direction, see what's coming, to not be ahead, to not be behind the time, but we need to try to keep ourselves in the forefront of those changes and understand what is coming, how we should improve our products, because all the products now have some AI chatbot. For instance, Notion, for instance, is a good example, and every other product which didn't have anything auto-generated in the past. So now they have AI, they have a lot of assistants, so AI is everywhere. You need to understand how to improve your product with modern, up-to-date features to make it competitive in the market. And judgment, focus, prioritization, and understanding what's coming next become more and more important for the leaders. And in the past, management work, not for sure for everyone, but it was very close to the managing a lot of different things like micromanaging, I don't know, being productive in process-heavy organizations, and you were usually part of the approval. I need to approve your PR, I need to approve your request to get new laptop, I need to approve your request to have access to some software. But now engineering leaders should become more enablers, because you need to enable your team to go forward very fast, because now we have like unlimited power. We have a lot of access to a lot of tools, and you just need to understand which one is the best one and allow your team to use it to go forward fast. And what teams are looking now, I think that in the future teams will become much smaller, more productive, more full stack, let's say, and more focused on the real outcome, which will be measured by the impact of this team, which kind of impact this team has in the overall company performance. And departments now should be converted into a mission-driven small pods, because there is no more need to have to keep the huge organization to build something. And as I already said, we need to focus more on coding, use AI prompt in the correct way, workflow automations, and understand system, think about distribution. And what else? So those organizations who are not adopting to those new AI changes, they will have, I think, some problems in the future, because smaller teams with this modern approach and open thinking, which are open to use new technologies, they go very fast, and you need to just catch up after those. If you are not adopting, it will be a huge problem, I think. And I would like to jump a bit, because we have very limited time. So, okay, 1 minute. And in the past, traditional workflow was some idea. Product team converted it into the tickets. Tickets were assigned to developers. They did it, then QA tested and released. Now, idea, AI-assisted prototyping, instant validation, iteration, and you getting feedback very fast. Again, changing your product very fast and then releasing. And I don't think that AI is a risk for us. We just need to use this tool, because it's just another tool, much more powerful than we had in the past. But with staying static, this is a problem. Relying on old processes, it's a problem. And experimentation, refusing experimentation is a problem. We need to be open and just catch up after the changes which are coming very fast. And I already talked about the teams. Let's go a bit forward. So managers should now understand again design much better, help others to grow, move forward very, very fast, and learn constantly to understand what's coming. And the best engineering leaders of the next decade will not manage more people. They will just create more leverage to unlock their teams to deliver more. So thank you. And if you have questions, I will be happy to answer.
Thank you for the presentation. It was a really good and interesting topic. I have actually two questions. How do you think the managers should measure the success of their teams in the era of these new AI tools? And what do you think about the AI leaderboards that a lot of corporate companies nowadays have?
Could you please repeat second question?
Yeah, what do you think about the AI leaderboards that a lot of corporate teams now have, like Microsoft, Amazon, and etc.?
Mm-hmm. So regarding the first question, what we personally do in our company, we provide kind of unlimited support to our engineers to use the tools. And we started to measure success. As coding is no more a challenge, you can generate code a lot. We start to think how much features people can deliver now. For instance, I'm pretty hands-on engineering manager. I spend about 70% or 60% of my time coding. And in the past, for instance, it took me 2 weeks to build a medium-sized feature in parallel with the management work. Now I see that I can do 2 times more in 2 times less time period. So during 1 week, for instance, I can do 2 product integrations because of this AI. So this is how we want to measure, and we just want to see that teams started to deliver more features. That's first. And regarding the second question, like, we don't have this AI leaderboard, and in general, I'm, to be honest, very against those kind of leaderboards, because in some companies I worked, I can't remember the exact name of a tool, but it analyzed your GitHub activity and give you some points, etc. So you did 10 commits, another one did 1 commit, etc. I don't think this is the right number for a measurement, because one person is coding the whole day and do 1 commit at the end with no bugs, for instance, and another one can write 10 lines of code and do commit. So looking at those numbers, they don't have any value, I think. So regarding this AI leaderboard, I'm not supporting those kind of things, because what matters is the real feature you delivered, the quality of the feature you delivered, and how it impacted the overall product and improved the ARR or MRR in the company. That's what's interesting.
Thank you very much.